All right. So you know how we start this out.
Yeah, how was your weekend?
You know, it was all right.
What'd you
Didn't
do?
I didn't go anywhere.
No?
No.
Well, you came here.
Well, that's not any fun. We just goofed around, did a little work around the house, ran down to Irvine, bought a 35-gallon gas tank.
That's pretty fun.
It is pretty sweet.
You do like that stuff, man.
Hey, it's got a little manual pump and it siphons or pumps. And it siphons really good because I had two 5-gallon buckets of gas out of the Datsun from taking it apart, and that's the whole inspiration. And it was cheaper to buy this cart pump thing than a couple of gas cans at AutoZone.
There you go. Yeah, we did a little camping trip. My buddy's going away, so did an overnight stay in Indio and hung out by the fire.
Nice.
Pretty fun.
Jealous. I'm deprived of desert right now. I need to get back into it.
Yeah.
All right, guys. So we got old Drew here with us today. He is going to be helping me out with some of my stuff here. It's can't do it all by yourself.
Yeah, not all the time.
So we figured we'd dive into some new subjects here and get it going, and have a good time. But the part we got to finish the opening because we say, "What'd you do this weekend?" And if it wasn't amazing, what do you wish you would have done?
I had the perfect weekend, I thought.
Well, and my follow up is, well, I didn't do anything, but I wish I would have went to the desert with you because then I would have at least got out.
Yeah, there you go.
Maybe next time.
Yep.
Cool. Well, all right. So you guys have seen what we got going on. We got some interesting things. It definitely. There's so many different subject matters to go over, and we're just trying to bring relevant stuff to you and give you some insight on it. So, we figured we'd circle back to the AI data
Hmm.
center kind of stuff. I'd hit on that a little bit late last year in October. We went to the Open Compute show, and that was definitely interesting. We said we'd come back to it and give you guys a little bit more insight. So, we do have a nice little PowerPoint about the things that we have going on. So we're going to kind of hit it at a high level here. And, if you're interested and wanted more information about this, all you got to do is ask. We'd
Hit
happily
us
give it
up,
to you.
dude. Hit our line.
We might even give you more information.
Too much, maybe.
It's been known to happen.
Right on. So, what is this AI heat wave? Like, how do you think it's going?
It's very interesting because I've been selling fans a long time, back to when you didn't even hardly need a fan,
Hmm.
and it's just amazing when you look at the type of things that generate heat within a computer or a server or things like that. And so as we really look at how cooling is handled in a data center, it's like it's so stinking hot that honestly there's not a ton of fans.
Yeah.
We're in the new world of water cooling, and it is something else because we're not talking about just a little something.
Hmm.
I mean, this is at the level of, I mean, if you scaled it up, it's like what's in your vehicle.
Right.
And it's not like what's in your Toyota Camry. This is like what's in a 3,000 horsepower drag car going down the strip. I mean, you're
Yeah.
talking about high performance stuff.
Hmm.
So, so yeah, you get to a point when air just can't do the job anymore. It's kind of like your car, right? I mean, you got to have water cooling, otherwise you overheat.
Right.
Can't just
Exactly.
blow a fan on the motor.
Yeah.
I
It,
wish.
so, why are AI servers creating more heat than a normal server then?
So, it's pretty interesting because when you go look at like an Intel current server chip, right? Those things range from like 3 to 500 watts, right? And 500 watts is no joke, right? That's something respectable to cool. You can do it with air cooling, fancy heat sinks. Guys, gamers will still put water cooling on there because you can run your fans a lot quieter.
Hmm.
But it's like you look at these GPUs, and the current versions of the GPUs can be as high as like 12 to 1500 watts.
That's crazy.
So you're talking 3x where the current standard server that's air cooled.
Right.
And then they're talking about, the next generation of GPUs that's coming out at the end of this year, going into next year, they could be as high as 3,500 to 4,000 watts. So you're talking in the scale of up to 5 to 8 times higher wattage output
Yeah, and
than
that's
what a
insane.
typical server thing would be. So, yeah, you got to have water. Sometimes you got to have fancy fluids because, just like in your car, if you put some stuff in there, right? Antifreeze or
Mhm.
radiator, whatever you want to call it, coolant, it is a different consistency than water, and it's meant to not evaporate and do all that stuff. But I think maybe we'll hit on that here in a bit.
Yeah, I got you. And, why is heat such a big problem with these servers?
These chips and everything in them, they like to perform at a certain heat load. And when they're running hotter, the efficiency tanks, right?
Gotcha.
It's kind of like the simplest thing is leave your cell phone sitting on your dash in your car when you're driving around on a warm day.
Mhm.
That thing will overheat so stinking fast, it's ridiculous,
Right.
because once it starts hitting a point, it can't come back
Mhm.
because of the heat load that's on it. And so, yeah, we definitely got to get into it and look at what the best options are for that.
Yeah. And are there any certain pain points, in these servers that engineers have been facing?
There certainly are. Let me have a little bit of my notes here just so I'm keeping track. But, the when we're talking about the pain points and the things that we want to look into here, um, we're certainly not trying to go out and engineer a solution with Meta or
Mhm.
Amazon or Google or somebody like
Right.
that, right? Those are tier one, way above average type things. What we're looking at as this world rolls out, having solutions that would be for tier two and tier three size companies that
Right,
have
yeah.
small locations. Maybe you get all awesome and you got your company and you need your own little AI data center and you only need 2 or 3 servers, right?
Okay.
That's gonna suit your needs just fine. Well, you don't need this massive system, right?
Right.
So, what we start looking at is what's going on at that level. So, the pain points there, you know, they lack space to get it done in the infrastructure,
Mhm.
right? Number one thing you hear out there is like, okay, where are you gonna get all your power and where are you gonna get all your water?
Right.
Right? So, and then if you're not managing your thermals right, then you start dealing with reliability issues, right?
Mhm.
And you don't want your stuff failing and burning out because
Well,
it's so
yeah.
stinking hot, right? And then if you're working on one data center, sure, it's expensive, but it's low volume,
Mhm.
right? So then it's like getting solutions that it can be adopted and integrated into
Mhm.
stuff that's a little bit lower volume.
Okay. And, what kinda solutions are we using here?
So, the when you're in the data center, right? We've got and we'll bring up some pictures here, right, on all this cool stuff. And by the way, the presentation here, we're happy to share it. This was you know, uh another open compute thing that we had done in Taiwan and had a deal we did there. But if you're interested in seeing the kind of specs that we have and where we're going and possibly have a conversation, just reach out to us and we're happy to share it. But what we're producing is they're called sidecars, right? So it's another rack. It looks just like the one the server would be in, maybe a little bit bigger.
Right.
But we've got sidecars that are liquid to air and air to air, right? And so in a smaller system that's not like insanely high compute,
Mhm.
right? You could go liquid to air, right? Because then you're like, you've got a system that's contained within this rack and not part of the whole HVAC system for the building,
Gotcha.
right? And then we have in row systems where it's liquid to liquid, technically, and that's when you're tying into the HVAC system. And, you know, some of the interesting stuff we got going because we're a fan manufacturer.
We are.
We've got these liquid to air systems that do have some fans in them, and these are special fans.
What kinda special fan?
They got LSD in them. And
They're
I'm not
trippy
kidding.
fans, brother.
They're pretty trippy, but you know
Yeah.
what? They're pretty dang smart too. So, there's all kinds of stuff going on in the LSD world today. But you know what? Our fans are on that gravy train, and LSD is for life self-diagnosing. So, we'll hit on that a bit as we go down home stretch.
Yeah. I got you.
But we got it's never a lack of interesting things over here, YS Tech.
Yeah. YS Tech loves LSD, man.
We like it weird.
Yeah, and you had mentioned something about, Intel Superfluid earlier. Could you hit on that a little bit?
Yeah, so, as we put these systems together, um, think of it this way, right? You can have these coolants that you would use like in vapor chamber heat sinks. You have heat pipes that have different cooling. It's not just water.
Mhm.
And so, as we look at the thermal properties and its ability to do its job and dissipate heat, not evaporate.
Mhm.
We don't really have an issue of freezing here, but if you're in a cold area and it's the water's going outside, you want to look at all that. And
Right.
so, yes, Intel has developed what they're calling superfluid.
Mhm.
The superfluid, I mean, we've got some studies here. You can look at a same exact cooling system, and just changing the fluid in it can affect your performance by, I mean, it's 4 to 6% at the fluid level.
Yeah.
But like one of the tests here, and we've got this little slide here where we can pop it up. I think we were saying that like the one system would do about 930 watts, and then you put the super fluid in there, and it was able to dissipate up to 1100 watts.
Wow.
So that's a pretty big increase just in a performance fluid being used.
Yeah.
So not only are we looking at the quality and integrity of the design, but all the components in it, so that you're getting the very best efficiencies.
Right. Yeah.
But, so getting back on this, we talked about sidecars, and,
Mhm.
we've got some really cool pictures showing the breakdown of it so you can actually kind of understand what's going on in there. Because when you talk about liquid to air, think of it this way: we're doing a closed system, right? So you've got the fluid in there. The fluid is going into the rack. All the servers have, for lack of a better word, a manifold system that's mounting on every GPU. Some servers have more than 2 or 3 GPUs in them,
Jeez.
right? And so then you have this whole manifold where all the water is going in there. Then it comes over into the rack that's next door to it.
Right.
Well, inside the rack, you'll see here on the picture that we put up, it's a massive radiator, just like what's in your car,
Mhm.
right? This one here, our 120 kilowatt system, has 14 200 millimeter fans in it. And we'll show you here in a minute, our fan with the Sebestial Smarts.
Yeah.
That bad boy is just shy of 1,100 CFM.
That's an insane amount.
So you're talking about over 15,000 CFM.
Yeah. That's high performance.
Getting her done. So we've got this is the liquid to air. Same thing, liquid to air, 120 kilowatts. The ATP on it, the approach temperature difference. Think of it, that could be a whole conversation in itself, but, think of you having a primary and a secondary unit. So if your primary is your radiator, and then the secondary is what you're trying to cool,
Yeah.
right? Or for all us normal folks, you got a radiator in your car, you got a radiator and an engine.
Mhm.
Primary, secondary. The
Right.
radiator and fan are cooling the fluid coming out of your engine. So it is just, it's pretty wild.
Yeah, sounds
But
like it.
it gets it done. And I don't even know where I was going with that thought, but it's like it's just combining all the things to where it just, or the ATD, it gets it to where that's looking at a factor of how efficient your system is,
Right.
right? I lost my train of thought there for a second, but back to the ATD. The smaller the number, the better, right? So if you're
Yes.
looking at it, you're reviewing it, and you see an ATD number, and you're like, "Geez, what the heck's that?"
Mhm.
And it's like, well, just know if you're under 15, right? Because we've got in some of ours, depending on it, 6, 10, I think some 12, right? And those are the degrees of ATD.
Mhm.
And that is just telling you the efficiency of your heat exchanger and how fast it can turn the heat around when it's bringing it in
I got you.
from the source.
Yeah.
All right, so we've got the liquid to air, and I was going to hit on the water, or liquid to liquid, is actually even more interesting, and we'll bring that little slide up here. That's when you have a manifold system,
Mhm.
all your water's coming out, but instead of cooling it in that, you've got piping then that goes up to the ceiling, and it's being pumped out to the main heat exchanger on the roof or outside the building.
Gotcha. Okay.
So that's like super level. That's
Mhm.
when, and those are handling something, I believe it's like 1.4 megawatts.
Jeez.
So you're not just talking about, "Oh, yeah, let's cool off 500 watts," I mean, it's like it's pretty wild.
It's doing the work, yeah.
Yeah. So, yeah. Sidecars, super sidecars, liquid air to air. I mean, all that stuff's going on. So, if you really want to get into it, reach out to us. We're happy to share that. Um, the other part of this, or I don't know, you're probably going to ask me in a minute, but I'm going to go ahead and jump the gun.
Go ahead, go for it.
So you're like, all right, well, you guys make fans, and this all sounds great, but it's like, are there any fans in this damn thing? Hey, the liquid to air,
Yeah,
where we said the 14 fans are, we've got that. And we did do a new 200 by 70 millimeter fan. We've had it on a product highlight, sometime over the last month.
yes.
And that bad boy's coming in just under 1100 CFM. For the AI data center, that's the whole the LSD thing, is so it can keep an eye on itself because you don't know what's going on. Preferably not failing.
Yeah,
But
well,
we can do the 200 millimeter fan for any industry. We have
mhm,
all kinds of IP ratings on it. If you were interested in the failure mode of this LSD technology, we're certainly happy to do it for you. But we also have a 200 by 50 that's out, and that guy is like 8 or 9 or 7 or 800 CFM. And for power, battery, energy storage, a lot of people are looking at that. We've got a lot of those in EV charging and stuff like that.
mhm,
So a lot of big, heavier applications that could be very interesting for.
awesome.
So that's a quick story on this stuff. I think we kind of hit the high spots on it, and
For sure, and I mean, if anybody needs, more in-depth info, we can obviously share that with them or answer any questions they may have.
yeah, you can. Drew can put his information out there because Drew does SDR work for us, and he's the first line of defense talking to folks when they're ready to engage, and he can kind of help navigate kicking it off and then get you in touch with engineering and sales and just start working through it.
I'll point you where you need to go.
Yeah, we had a pretty good guy come on this last week working on a nice little heat sink and fan need, and
Mhm.
he's just looking at a fan or a blower to go on a device he's got going, and we started looking at it, and we're like, hey, we do all this. It's an enclosure, and needed to do a simulation and figure out the best flow pass and get the right blower picked, and so we're like, shoot, hey, let's just do a ding simulation on it, and we'll tell you exactly what you need and how to do it and where to do it and when. And so
Yeah,
we got all the 3D files together today, and
yeah, I saw those come
engineering will
in.
probably be able to give us a timeline on it tomorrow, and we'll probably have them a simulation back sometime next week.
Yeah, I'm ready to rock and roll with that.
Go dominate his industry with a cool solution.
That's right.
Cool.
Sweet deal, guys.
All right. Well, I think Drew survived his first show today.
I think I did all right. Not used to being in front of the camera. Behind the
Not too
scenes
hard, right?
guy. Nah, it's normal conversation.
Yeah.
Had a good time. It's
Cool.
always a good time with you, Charlie.
Not always.
Well, most of the time.
That's right. Cool. Well, we appreciate you guys taking a look. Like, subscribe, do all that fun stuff, and keep it cool.
Yeah, we'll see you again next week, guys.
Later.